Okay, this lesson is on more trig graphs and reciprocal graphs. So the first graph we're going to look at is from your set of worksheets, y equals 3 sine of x minus pi on 4. So the first thing we need to do before we sketch any trig graph is to work out, do a bit of working out. So we'll have a look at the amplitude. And you can see that's there, that's 3. The period, and that's going to be 2 pi on n, where n is just the coefficient of x, which is 1, so the period's just going to be 2 pi. And now this little bit here, minus pi on 4, because it's inside the brackets, it means the whole graph is going to be shifted pi on 4, and the minus means we're shifting to the right. So very similar to how when, say, we had y equals, in the prelim course, x minus 2 all squared. That was shifted to the right 2 units, because just say if you sub in here x equals 0, then you get y equals negative 2 all squared, which is 4. So, or if you were to sub in, say, y equals 2, then you get 2 minus 2, which is 0 all squared. So that's where the y-intercept is, so that's why it's shifting to the right. Also, you can use the same logic and reasoning in our trig graph. If you make x equal pi on 4, then you get sine of 0, which is 0. So, you know that's where the graph, that's one of the coordinates on the graph, pi on 4, 0. Okay, so one way of sketching this graph is to just draw y equals 3 sine x, and then you can then shift it to the right by pi on 4 units. So in blue, let's draw y equals 3 sine x. So the amplitude is 3. Put the amplitude of 3 there. Same distance down here will be negative 3. And our period is 2 pi. So we'll make that 2 pi. That one's pi. Pi on 2. 3 pi on 2. And let's just sketch this between negative 2 pi. Ooh, we'll make that negative 2 pi. We'll sketch it between negative 2 pi and pi. So, sine of the 0 is 0. We're going to go up to 3, down to 0, down to negative 3, back to 2 pi. So, it's going to be looking a little bit like that. Down, 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 down. Alright, that's y equals 3 sine x. Now, we have to shift this to the right by pi on 4. If that first marking there's pi on 2, pi on 4 is going to be halfway just there. So we're starting our graph here, pi on 4. And every value we're going to shift across pi on 4. Yeah, so shifting to the right by pi on 4. Okay. And then we're just going to sketch that, connect our little dots. Alright, now it's good to mark in some of those x and y intercepts, so let's see what we got. If we were to fill in all those extra little markings in between the big markings that we had on the scale there, you're starting off with 1 pi on 4, 2 pi on 4, this would be 3 pi on 4. 4 pi on 4, 5 pi on 4. 6 pi on 4, so that's going to be 7 pi on 4. 8 pi on 4, and then that's going to be 9 pi on 4. Maybe it'd be better if the graph and the scale was bigger to fit in. To fit in the numbers a bit easier. Alright, going down to the negative direction, that's negative 1 pi on 4, negative 2 pi on 4. That would be negative 3 pi on 4. Negative 4 pi on 4, negative 5 pi on 4, negative 6 pi on 4, negative 7 pi on 4. So the reason why this is useful is when we start using graphs to solve equations. Alright, so there we have in red, y equals 3 sine of x minus pi on 4. That's the x-intercepts. We haven't actually marked in this y-intercept here. So the y-intercept occurs when x equals 0. You can work that out. when if you let x equals 0, you're going to get y equals 3 sine of negative pi on 4. Now remember, negative angles are measured clockwise from the positive direction of the x-axis. In that fourth quadrant, sine is negative, so negative pi on 4 is the same as negative 3 sine of pi on 4. The sine of pi on 4 is 1 on root 2. Times by negative 3 is negative 3 on root 2. So our y-intercept just there is negative 3 on root 2. Okay, harder graph is question 5F from exercise 5.7. Okay, that 4 there is our amplitude. Okay, our period is 2 pi on 2, which is pi, and plus this bit here, plus pi on 2, means we are shifted to the left this time, because plus means you're moving in the opposite direction by pi on 2. So because we're shifting to the left, or shifting a graph to the left, it's easier, I think, if we draw the graph that we're going to be shifting. And this in this question says we want to graph it. Our domain is between 0 and pi on 2. So let's make that value there with pi on 2. Sorry, with 2 pi. So we're graphing it between 0 and 2 pi. Is that what I said? Can't remember. Alright, that's 2 pi. Oh, that's pi. That's pi on 2, and then that's going to be 3 pi on 2. So let's first graph y equals 4 sine 2x. And then the difference between this graph and the graph that we need to graph is that we just have to shift our graph to the left by pi on 2, and then we'll get our new graph. So 4 sine 2x, the amplitude is 4 and the period is pi. So if we say that's worth 4, same distance down would be negative 4. Remember, sine always starts at 0. Sine of 0 is 0. Now a period of pi means we're going to go up, down, let me trace this out, up, down, back, sorry, all the way down here, to pi, and that's one cycle. So drawing that out, it's like you're going to be there, 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 and then back to here. So, but because we have to draw it between 0 and 2 pi, we have to keep going. So one more period. Oh, this is terrible. Drawing that bit again. Not the best graph. Y equals 4 sine 2x. Alright, now the graph that we want needs to be shifted to the left by pi on 2. So there's pi on 2, we're shifting that to the left. That point becomes now this point here. This point here would become here. And this point here comes there. This point here becomes up here. This point here becomes over here. This point here ends up here. This point here ends up here. So we're going to be going like this. Oops. Maybe do these in pencil. What do you think I'm going to go from here? That's right, it's cyclical, so we're going to just keep going. And now we've continued that graph between 0 and 2 pi. So the red graph is y equals 4 sine of 2x plus pi on 2. Next graph. Oh, this is a combination graph. We've got to draw two separate graphs, and then we have to use those two separate graphs to then draw a graph which is the addition of these two graphs. So let's look at y equals 2 cos x. Amplitude, you can see, is 2, and the period is 2 pi. So let's draw that one in red. And we have to draw this between 0 and 2 pi, so that will be pi. That's pi on 2, that's 3 pi on And then our amplitude of this one's going to be 3, and the period is also 2 pi. So let's make our markings go up. 1, 2, 3. Please use a ruler or your math aid to make sure those little markings are equal distance. -1, -2, -3. Alright, because of 0 is 1 times by 2 is 2. So starting up there. Coming down here, pi will be -2, back to 0, and finishing off back because of 2 pi is 1 times 2 is 2. Okay, let's draw that out. Oh, I thought I turned off those off. Okay, continuing on there. Oh, that's terrible. Let me draw that out again. Alright, that's y equals 2 cos x between 0 and 2 pi. Let's draw in blue, y equals 3 sine x. So amplitude 3, we're starting at 0, sine of 0, 0. Going up to 3, down to 0, down to -3, and back to 2 pi there is 0. So that one was a lot better. So that's y equals 3 sine x. Y equals 3 sine x. Alright, now, part B, graph then y equals 2 cos x plus 3 sine x. So there's two ways of doing this. I think the easiest way is just to do it on the graph and add the y coordinates at each as you go along the graph, add the y coordinates together. So here we're adding together 0 plus 2, which is 2. Or you could set up a table of values and put them in the table of values. Here we've got, what's this, roughly about 1.8 plus 1.8. So that's going to be about 3.6. Okay, here we've got 3 plus 0, which is 3. Here we've got 0 plus -2. Here we've got about -1.8 plus -1.8, which is going to be about -3.6. Here we've got 0 plus -3. And back here we've got 2 plus 0. So we've got what we call a couple of cheat points. So we're just going to be adding those, just connecting the dots again, really. There you go. So we've got our purple line is y equals 2 cos x plus 3 sine x, just by getting our cheat points by adding together the y values. As you go along, adding together the y values of each of our two separate graphs and then connecting the dots. Okay, now at some of the reciprocal graphs. So to draw y equals cosec x, cosec is 1 over third letter rule sine x. So before we draw cosec x, it will help if we draw sine x. So it'll be going like this. Hopefully you know what y equals sine x looks like now by now. If that's 2 pi, and that's pi, and our amplitude is 1. That'd be -1. And we're going to continue. Because sine x is an odd function. Okay, so there's what y equals sine x. Now we're going to draw the reciprocal of that, which is cosec x. Now, you know that in a fraction, the denominator cannot equal 0. So anywhere where sine x equals 0, we're going to have an asymptote. So right there, there we've got sine x equals 0. Same with there. And there. Now, what is the y value here of sine x is 1. The reciprocal of 1 is 1 divided by 1, which is 1. So on cosec x, that's going to be a point, 1. Likewise, down here, the y value there is -1. 1 divided by -1 is -1, so that's going to be another cheat point. Up here we've got 1 and -1. Now think about these little y values here. They're very small values of y. Say, for example, 0.001. If you did the reciprocal of that, 1 divided by 0.001, you get a big number. So that helps when you're graphing these big numbers. Same with up there. Okay, same with down here. You get a large negative number. And the same thing's going to happen because it is a periodic or cyclical type of graph. So in red we've got y equals cosec x, and I've just drawn it between -2 pi and 2 pi, but obviously the domain of sine x is all real x, so the domain of cosec x is going to be all real x. It's going to continue in both directions. We're going to use to draw sec x. Now sec x is the reciprocal of cos x. So let's draw cos x first, then we can draw sec x. So cos x, amplitude is 1, period is 2 pi, so it finishes just here at 2 pi, or one cycle does. That didn't go through the x-intercept. That's a bit better. Alright, and let's continue that the other way. Remember, this is an even function, cos x, symmetrical about the y-axis. So then let's draw y equals sec x. So we're taking the reciprocal. So remember, everywhere where cos x equals 0, we can't have 1 divided by 0, so there's going to be an asymptote there. Okay, and everywhere else probably, yeah. Alright, the reciprocal of 1 is 1. 1 divided by a very small number is a very big number. The reciprocal of -1 is -1. So we're going to be going like this, like this, like this, and like that. So in blue I've just got sec x between -2 pi and 2 pi. But obviously, just how the domain of cos x is all real x, so with the domain of sec x. Oh, except for, I guess, where the asymptotes are. Same with cosec x. It's not really all real x, because there's those x values with asymptotes where x can't equal. Slight correction there. Alright, cot x. Cot x is the reciprocal of tan x. Or you might remember that tan x is sin x on cos x. So you could say cot x is cos x on sin x. The reciprocal of tan x is cos x on sin x. So let's draw sin x and cos x, and then we'll divide those two functions. So what if we go like this? I think I drew those dots very well. That's 2 pi and that's pi. So this is sin x, that's right. Going through those values. Alright, so in red we've got y equals sin x, just graph between -2 pi and pi. It's -2 pi. Now let's draw cos x in blue. Ooh, not the greatest. There we go. Y equals cos x. Should be a little bit more rounded there. Alright, now we want to draw in purple y equals cot x. And cot x is cos x divided by sin x. So, same reasoning. Wherever sin x equals 0, we're going to have an asymptote. Sin x is the red curve. So we're going to have an asymptote there. There. At pi. At 2 pi. negative pi, negative 2 pi. Alright, then we're drawing cos x divided by sin x. So cos x is blue. And we're dividing by the red. So for every y value, we're doing the blue value divided by the red value. So, for example, just here, they're both the same value. Same value divided by same value is 1. So you can put that there as a 1. That'll be 1. 0 divided by 1 is 0. And down here we've got a negative divided by positive, which is negative. So, see how it looks kind of similar to the tan x curve, it's just going reversies. Okay, here we've got 0 divided by negative 1, which is 0. Negative divided by negative in, see this little section here, negative divided by negative, which is a positive. And then down here you got positive divided by negative, which is negative. 0 divided by negative 1 there, and 0 divided by positive 1 there. Some more cheat points. In this section here, we've got another negative divided by a negative, which is a positive. And you can see that cot x is just, it's just like tan x, but it goes the other way.